Okay, so today we're going to talk about solving quadratics using the quadratic formula. But before we do that, we're going to figure out where the quadratic formula comes from. We're going to actually derive it. Because at this point, you know enough math to get to this really cool formula. Okay? So we're going to start with ax squared plus bx plus c. And we're going to use completing the square to come up with the formula. All right, so our first step in completing the square is always to move the c over, right? So this is going to be ax squared plus bx plus c equals 0. In completing the square, what's our next step? Yeah, we have to take out the a. Your a value. I know I'm right. I'm just kidding. I'm wrong quite often. All right, so I take out the a. This is ax squared, a times x squared plus, if I pull out an a here, I'm going to have b over ax. Just go with it. You're fine. Can't be mad yet. This is like step 2. All right. Let's go ahead and complete the square. Take your b value. That's b over a. I need to half it, so what can I multiply it by? 1/2. So I get what? b over 2a. Okay, so this b over 2a, I box it, square it, and I get b squared over 4a squared. Write it. Okay, and now let's figure out how to counteract it. Okay, what's really happening is b squared over 4a squared is being multiplied by a. So I'm going to come down here and see what that looks like. So I've got b squared over 4a squared times a, and I can treat that as a over 1. So I get ab squared over 4a squared. Because I'm seeing, the reason I multiplied it by a is because I'm trying to see what I really plugged in so I know how to counteract it. Okay? Can I cancel these a's? Yeah. So this is a, this a is going to cancel with this squared, so I've really added in b squared over 4a. So what am I going to counteract with? Minus b squared over 4a. Okay, sorry, I forgot that equals 0 from before. All right, let's rewrite this as in vertex form. So this is a times what? X plus b over 2a squared plus c minus b squared over 4a equals 0. Okay? Now we got it. We're trying to solve for x, so let's get this stuff to the other side. So I'm going to get a times x plus b over 2a squared equals, when I move c over, what's it going to be? Negative c. When I move the b squared over 4a over? Plus b squared over 4a. Okay. I want to try and combine negative c and b squared over 4a. Okay? So I've got to get what? Yeah, I've got to get it into a common denominator. So my common denominator is going to be 4a. What could I multiply negative c by to get something over 4a? I got to multiply by a fancy form of 1. would you agree that I could multiply by 4a over 4a? That's just like multiplying by 1, right? So I haven't messed anything up. So negative c times 4a is minus 4ac. And then if I put c over 1, 1 times 4a is 4a. Because I'm trying to get a common denominator here so that I can combine these two fractions. Okay? So this is a times x plus b over 2a squared equals minus 4ac over 4a plus b squared over 4a. Okay, now we can go ahead and combine, right? Yeah, what's that numerator going to become? Could I write it as b squared minus 4ac over what?
Over 4a.
4a. Great. All right. What do you think our next step's going to be? Now I'm trying to get x by itself. Divide by a. What's another way I could think of dividing by a? Multiply by 1 over a. Okay, so this a and this a cancel. So I have x plus b over 2a squared equals, multiply your top, b squared minus 4ac over, what's 4a times a?
4a squared.
Now you do. Okay, we okay? All right, what are we going to do next? Yeah, let's square root. So when I take the square root of the left side, I'm going to get x plus b over 2a equals plus or minus times the square root b squared minus 4ac over 4a squared. All right, what could I do with that big square root now? Split it. So this is x plus b over 2a equals plus or minus square root of b squared minus 4ac over the square root of 4a squared. What is the square root of 4a squared? 2a. So this is x plus b over 2a equals plus or minus the square root b squared minus 4ac all over 2a. Okay, only one more step. Well, two more steps. What are we going to do? Okay, subtract b over 2a. So this is x equals negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. And what do you notice about our denominators? They're the same, so we can combine these. So we get x equals negative b plus or minus b squared minus 4ac all over 2a. What is that? That's the quadratic formula.
Wow. That's a lot of math. That works out.
All right. Who's going to sing? All right, so it goes. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. song. That's fine. I'm sad for your childhood, but that's okay. You've got to memorize the formula. You do need to know the formula, okay? So either learn a song, get a friend to teach you a song, memorize it yourself, but you do need to learn the formula. Yeah, or you could just derive it each time. That sounds fun. But isn't that cool that you know the math to get you to this huge formula? Okay, take a second, write this down. Okay, so here's your quadratic formula. This works. We use the quadratic formula to solve, or to find solutions, or to find x-intercepts, or to find roots, or to find zeros. All of those things you can find using the quadratic formula. That's why it's x equals. Okay? It works every time. You can use the quadratic formula with any quadratic function. You will always be able to find your roots with the quadratic formula. It's not always the most efficient one, okay? But it does work every time. Tati? Okay? All right, Jason. Sorry, Reese. Okay, so we use completing the square. The main reason we use completing the square is to go from standard form to vertex form. Once you have it in vertex form, it's possible to solve. Okay? But the main purpose of completing the square is to turn into vertex form. The main and only purpose of quadratic formula is to solve. Okay? All right. That part that I underlined in pink, okay? That part right there, that b squared minus 4ac, that is called the discriminant. That is the discriminant. The part that you take the square root of is your discriminant. And the discriminant is really, really useful in telling us what kind of solutions and how many there are. Okay? Because it's what we take the square root of. And whether we take the square root of a positive or a negative helps determine if we're going to have real or complex solutions. So let's think. If b squared minus 4ac is greater than 0, that means I'm taking the square root of what kind of number? Positive. And when I take the square root of a positive number, do I get a real number or an imaginary number? Real. So if your discriminant, if b squared minus 4ac is greater than 0, you're going to have two real solutions. If your discriminant is equal to 0, if your discriminant is exactly 0, that means we take the square root of what? 0, which just gives me 0. So how many solutions would I end up with? Just one. Because it would be negative b plus 0 and negative b minus 0. Aren't those both just negative b? Yeah. So this is one real solution. No, the solution is not 0. Okay? So think about it, though. It's really cool how all of this works together. If a graph has one real solution, what does that tell us about the vertex? It's on the x-axis, right? And remember that, so that means that this vertex is the solution, right? The x value of the vertex. How do we get the x value of a vertex from standard form? No, from standard form. From standard form, how do we get the x value of the vertex? Negative b over 2a. Well, think about this, guys. If I take the square root of 0, that just becomes 0, right? Isn't that negative b over 2a? That's where that comes from. Okay? All right. If b squared minus 4ac is less than 0, I'm taking the square root of what kind of number? No, I'm taking the square root of a negative, which creates an imaginary number. So this is 2 non-real or complex solutions. No, there will never be just one imaginary solution. Remember that they come in pairs of their complex conjugates. So it's always 2 plus 3i and 2 minus 3i. They always have to come in pairs. Okay? All right. Let's give this a shot. F of x equals x squared plus 10x plus 2. I think it's good to start by deciding what a is, b is, and c is. So a is 1, b is 10, and c is 2. All right, so let's go ahead and start. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay. You're always going to want to start by simplifying your discriminant first. Not only does that make your life easier, but it tells you exactly what kind of solutions to expect. 2 real, 1 real, or 2 complex. So let's simplify our discriminant. 10 squared is 100. Minus 4 times 2, 8. So we get 92. Greater than 0, equal to 0, or less than 0? Greater than 0, which tells me what about my solutions? 2 real solutions. Okay? So let's go ahead and rewrite this with our discriminant under our radical. So x equals negative 10 plus or minus the square root of 92 over 2. Okay? What do you think we should do next? Yeah, let's simplify the square root of 92. So it's kind of a big number. I'm not so sure what goes into it, but I know 2 goes into it, right? So 2 and 46. And then what? 2 and 23. So I see a pair of 2's, which tells me what? 2 root 23. All right, so we have x equals negative 10 plus or minus 2 root 23 over 2. Okay, from here, to make your life as easy as possible when simplifying these, it's always best to split them and then try and reduce. Okay? If you try and reduce here, you're likely to make mistakes. It's best to go ahead and split these. So if I want to split this into 2 separate fractions, I'm going to get x equals negative 10 over 2 plus or minus 2 root 23 over 2. Does negative 10 over 2 simplify? What does it give me? Negative 5 plus or minus. What about 2 root 23 over 2? Yeah, square root of 23. Yeah, you can leave it like this. It is important to notice, okay, this is two solutions. So you could also write it this way, but you also want to just be able to recognize it as negative 5 plus root 23 and negative 5 minus root 23. Are those real? Yeah. So we've done what our discriminant said to do. Questions? So these are real, which means what about the graph? It crosses the x-axis. Which way does this graph open? Up. So where must the vertex be? Below the x-axis. Good. All right, let's try again. All right, so let's identify A, B, and C. Let's go ahead and set up our quadratic formula. X equals negative B, which is 1. The opposite of negative 1 is 1. Plus or minus the square root of B squared minus 4AC all over 2A. Everyone okay with that? All right, simplify your discriminant first. 1 squared is 1. Minus 4 times 2 is 8, times 2 is 16, so we get negative 15, which is less than 0, which tells us what? Good. Or you could say 2 complex solutions. All right, so I've got x equals 1 plus or minus the square root of negative 15 over 4. All right, how does the square root of negative 15 simplify? Okay, good. So this is 1 plus or minus I root 15 all over 4. Now, I recommend you always split because it's easiest to simplify. But in this case, you have to split because it's a complex number. And complex numbers always have to be written as the real part plus the imaginary part. Okay, so let's go ahead and rewrite this. X equals 1/4 plus or minus. You can either write I root 15 over 4 or you can write root 15 over 4I. Do either of those simplify any further? No. Are those two complex solutions? Yes. Questions on that one? Yeah, Ryan? You may. You're just going to see it more often with the I behind because complex numbers always come in the form A plus BI. Okay? Yeah. Yeah, I think you should always split it. But like on number 1, you technically could have written this as 5 plus root 23 over 2. Or 5 plus 2 root 23 over 2. Yeah. This one you have to split because it's complex. All right, I want you to go ahead and set up this one. I don't understand what you're asking.
Why would you not do what we did yesterday? Like on these problems?
Well, you technically can use completing the square to solve this. But quadratic formula and completing the square can both always be used to solve. It's going to be a personal preference which one you prefer solving with if things don't factor. Yeah, but completing the square has another purpose, and that's going from standard to vertex form, which is really the main purpose of completing the square. As you finish up, you can look up here to start checking your work. What's your discriminant in this function? This is 6 squared, negative 6 squared, which is 36, minus 4 times 9, which is 36. This is 0. So when your discriminant is 0, what does that tell us? One real solution. So this is x equals 6 plus or minus the square root of 0 over 2, which just gives us what? 3. Everyone see that? Okay, now this is a particular problem where, on a test, if I were given the choice, I'm not going to use the quadratic formula here. You can factor this. And to me, if you can factor, you should, because it's easier. Notice that this is the factors of 3 that add up to negative 6. So this would factor into x minus 3 times x minus 3, which is x minus 3 squared, which is an x value of 3. Okay? Did you get your question answered?
Yeah, I figured out that you're supposed to be
Okay. Okay, notice that I've continuously repeated the word discriminant today. Yes? Okay, there's a purpose behind that. Year after year, people get to this test, and it's like they've never heard the word discriminant. Make sure you know that word, and you know what it helps you do. It helps you figure out what kind of solutions and how many. 2 real, 1 real, or 2 non-real or complex. You need to know that word, okay? If you just think of it as b squared minus 4ac, when you see that word discriminant on the test, you're going to blank. So make sure that's one you kind of stick in your brain. It could ask you, what is the discriminant? Or what does the discriminant tell you? Or how would you find it? It could ask you any of it. You just need to be sure you know what that word means. Okay?